Okay, we're asked to simplify this expression, and we have a bunch of radicals added together. Right now, none of our radicals match. I have the square root of 20, the square root of 18, and the square root of 32. So what this means is right now, I can't add or subtract any of these, because remember, you can only add or subtract radicals if they match completely. That means, for instance, I could add 2 times the square root of 2 plus 2 times the square root of 2 because they're both square root of 2's, so I could then add the coefficients. Radicals, you really treat them just like you do any variable, in that if they match, you can add their coefficients or subtract their coefficients, as the case may be. But if they don't match, you can't, and they stay separate. But if I look at these 20, 18, and 32, you'll notice none of them are prime numbers. I might be able to break them down, and then it's possible I might be able to get them to match by pulling out whatever I can of the perfect squares. So I'm going to simplify each one of these. So as I look at 20, I want to look for what multiple can I rewrite as to give myself a perfect square. So look at 20. Well, 1 and 20 is an option. Well, I could take the square root of 1, but that wouldn't help me. I'd still be left with 20. 2 and 10. Oh, no perfect squares there. 4 and 5. 4 is a perfect square, so I'm going to rewrite this. And 4 stays out here, so I'm going to rewrite 20 as 4 times. Then I'm going to do the same thing here with 18. So look at 18, 3 and 6, nope, 2 and 9. 9 is a perfect square. Now I'm going to do the same thing, 32. Okay, 4 and 8, no, but the 4 is promising. There's another 4 in 8, so 16 times 2. And really, you're just going through the multiples, looking for one that might possibly be a perfect square. So, looking at these, I'm going to rewrite these. So I have the square root of 4, the square root of 5, square root of 2, the square root of 9, and 2, and 16. Now I'm going to take the perfect squares. So I'm going to take this one, and this one. And this obviously was our goal, is to rewrite it so we could do that. So then this becomes 4 times 2, because that's the square root, and the 5 stays there because I haven't done anything with it yet. 3 times 3, that's the square root of 9. 2 stays there. 5 times 4, square root of 2. So then here's 8, the square root of 5, minus 9, the square root of 10, the square root of 2. Now as I look at this, do I have any like terms? Yes, I do. I have the square root of 2. So this 8 to the 5th, that has to stay here. And then I have here, I have 9 plus negative 9. Oh, don't forget my negative. Negative 9 plus 20. Okay, so that gives me plus 11 root of 2. So this now is my final answer. I have a radical 5 and a radical 2, so this is done. But I was able to simplify it down. I got rid of one term, and I got everything nice. I got everything as far down, applied everything I could, and now this is my most simplified answer. You could, of course, get a decimal version of this, but this is a more precise answer because I never did any rounding. So this is the most precise answer, and this is the answer you're going to want to give. Unless, of course, you're told to find the decimal, this is the answer I'm expecting to see as your final product.